Our last session of the day, but after this session ends, we will be kicking off some Birds of the Feather sessions, just one today, based on voting in channel. For those who are here, we're going to have an off-the-record discussion about driving organizational change from the bottom up. I know something that's a number of folks have talked about today and how they get buy-in from across the org. So we'll have an off-the-record discussion, which seems like a great way to lead into end-of-day happy hour. So before we do that, we have one talk, and that is Mckay speaking about mapping the IAM universe. Would like to also thank our sponsors, specifically Lacework. The Lacework Cloud Security Platform delivers security and compliance across multi-cloud environments, workloads, containers, and Kubernetes. Customers drive down costs and risk by consolidating redundant tools, reducing inaccurate alerts, and eliminating manual rule writing. Please welcome Ian.
Thank you very much. Hi, everyone. Welcome to my talk, Mapping the AWS IAM Universe. My name is Ian Mckay. I'm the cloud lead at Kablamo here in Sydney, Australia. And I'm also an AWS community hero and Amazon Partner Network ambassador. Today, I'll be taking you through a quick IAM refresher. We'll talk briefly on least privilege. We'll talk about the problems with the Service Authorization Reference, or SAR. Talk about my attempt at fixing those problems. And I'll touch briefly on what's next for me. So let's jump into a quick IAM refresher. Here we have an IAM policy, and this policy consists of one or more actions, one or more resources, and optionally a number of conditions. But how would you find out the name of these actions or the structure of these resource ARNs or what conditions are available to you? Well, typically you'll see a page like this. And this is a Service Authorization Reference, or SAR. The SAR is the AWS provided source of truth for all of AWS's IAM permissions. These IAM permissions are usually, but not always, mapped directly to the name of an API method. So for example, in EC2.start instances, that maps directly to the permission EC2:start instances. But that isn't always the case. So for example, S3.list buckets maps to the IAM permission S3.list all my buckets. So you can see that this always isn't the case. The SAR is typically represented as a table, which has the name of the action, a description of the permission, an access level, which is list, tagging, read, write, or permissions management, the resource types that relate to the permission, where an asterisk represents whether it's required or not. It can optionally have some condition keys, which you can apply to the actual action itself. And it can also have some dependent actions, which are other IAM permissions that are required for the root permission to be effective. Let's talk briefly on least privilege. And least privilege is when you assign only the permissions required to perform a certain function. So broadly scoped policies don't lead to privilege escalation or level of movement or things like that. So here we have an IAM policy, and most people would say this isn't least privilege because of the wildcards in the policy. But what if we limit it by the service? What if we limit by the action itself? At this point, people start to say that this is least privilege, but we can go deeper. What if we limit by the resource ARN itself? At this point, most people would consider this least privilege, but that we can go deeper again. We can add all these conditions in order to ensure that the context of the request is what we expect. And so people's context of what least privilege is can change depending upon what they're working on. There are a few tools for achieving least privilege in the wild, and these primarily use AWS CloudTrail. In the open source world, we have things like TrailScraper by Florian or Cloud Tracker by Scott Piper and the Duo Labs team. In the AWS world, we also have IAM Access Analyzer. Generally, these tools can scope down to a specific action, but often not to the resource itself, as the details required to construct the ARN in the resource field is not available in the CloudTrail log entry, so we don't have enough information to make that determination. Let's take a look at this in the wild. Here we have the documentation for Amazon FinSpace. Amazon FinSpace is an AWS service which generates secure environments for storing financial data. And in its security best practices, we see that it does indeed say to implement least privilege access. What does that actually look like in the context of the rest of the documentation? Well, unfortunately, it doesn't look good for them. They go out immediately and tell you to apply administrator access policy, which is not ideal. They do have a optional managed policy to apply, but that's not much better either. It has that wildcard on the fin space namespace. So you could say, well, why don't we go to the Service Authorization Reference and look up these permissions? Well, unfortunately, the fin space IAM permissions are nowhere to be seen in the Service Authorization Reference. They simply don't exist. And so we're left dry to figure out what these IAM permissions are. And these are some of the examples of where the SAR might not actually be the source of truth that we're hoping for. Let's talk about IAM Live. IAM Live is an open source tool I created earlier this year that generates an IAM policy from the AWS calls you make locally. This works with the AWS CLI, the AWS SDKs, and most tools using those SDKs, so things like Terraform. This started with a client-side monitoring mode, thanks to some awesome research by Scott Piper and his huge documentation on that, so check out his work on that. The way it works is that when you make a request with the CLI or the SDKs, it actually spawns off a second packet on UDP port 31000. And this contains some analytics about the request, but that does include the service, the action, as well as some region information. And so we can start to construct a valid policy out of that. But I wanted to go deeper from this. So in my second iteration, I added an embedded HTTPS proxy mode, and that gathers all of the properties to construct the full resource ARN. So you can see on the right here that instance ID is being captured and being propagated into my IAM policy. In this iteration, I also made a note to add the AWS account ID, which is determined by the access key ID, which is in the headers. And that's thanks to some awesome research by Aidan Steele based on that. So thanks to his work on that. Let's take a look at a quick demo of IAM Live. Here I have two console windows. In the top window, I'm going to run IAM Live in proxy mode, and that'll just sit there waiting for some requests to come in. In the bottom window, I'm going to execute IAM create user with a specific username and a specific path. And when we execute that, the policy in the top is generated, along with the context of the path and the user, as well as the response returned correctly in the bottom. And you can use this in your own tooling or in your own applications to figure out what those policies are and what the context of the application is doing. Let's talk about some of the problems with the SAR. There are some fundamental problems with the SAR. One of the biggest ones is undocumented actions. As of March 2021, there were 378 actions at least that we discovered in the SAR, and that represents about 4% of the ecosystem. This was made by constructing a probable list using the API methods that didn't have an associated permission, and then confirmed by calling these methods, or fuzzing, using the API and a zero permissions user, and then interpreting the error responses. So those error responses might look like user X does not have permission Y on resource Z. And so you can interpret those responses to confirm that those IAM permissions actually exist. There are some missing or poor resource type information. So often resource types might show a star or have a star on the end of an ARN or have a very generic resource ID. There are often misindependent action information. IAM pass roll is particularly egregious in this area. The SAR only documents about 60 of the well over 300 IAM pass roll dependencies found. And that's thanks to some awesome research that Noam did on that. So check out his research. There are also these dependent action chains. So that's permissions that rely on other permissions, which rely on other permissions. So in the example I give here, enq create broker depends on EC2 VPC endpoint, which itself depends on Route 53 associate VPC with hosted zone, which itself depends on EC2 describe VPCs. So you have these long graphs in order to construct your policy correctly. There's lots of inconsistency within the SAR. So there are spaces within resource names, so bot space version or function space alias. There are often incorrect resource type references. So QuickSight create dataset requiring a data source. And there's often incorrect region casing, so a lowercase region or a lowercase account. We can see the account ID variable being used instead of the account variable, as is documented in the IAM policies. There are sometimes incorrect ARN formats altogether. So a snapshot schedule requiring a parameter group name, or a dedicated IP pool requiring an email template name. And these inconsistencies can lead to issues if you're using this data set as a source of truth for yourself. And then there are just some weird ARNs. So there are sometimes these hints in the ARNs, which is sometimes not helpful. There are camel case in ARNs, there are uppercase in ARNs. There are mandatory leading slashes in ARNs. There are mandatory trailing slashes in ARNs. Dashes in variables, colons in variables, optional variables, which is something I've never seen before, and sometimes barely populated ARNs that don't even get the service right. And so these issues are very prevalent within the SAR. But I really wanted to fix these problems. And you might say, well, the way to fix these problems is to hit that feedback link on the page and just raise a ticket. The problem with that is that the data set that underlies the SAR is not owned by a core IAM team. It's actually presented to the IAM team from the service teams themselves. So when you hit a feedback link and type in what your issue is, it can often take months for that detail to propagate back into the SAR. But that wasn't good enough for me. So I made my own source of truth. iam-dataset is an open source of truth, which utilizes the work of a bunch of other open source contributions. So Parliament by Scott Piper and the Duo Labs team, as well as Mammoth by Victor Grunu. And this is really meant as easier crowdsourcing of IAM inaccuracies. The core of the IAM dataset is an API method to IAM privilege mapping. The mapping is the primary source for IAM Live. It has over 10,000 API mappings and over 100,000 lines of JSON. It took me about 3 months to build the initial version of this, and it was built using a custom mapping tool, which I'll show you shortly. The way it works is that we have an API method in a huge array within the JSON file, and this has the IAM permissions that are associated with that method. So for auto-scaling put lifecycle hook, we have these resource mappings which represent the variables within an ARN template. So group ID is asterisk because we don't have that context, but group friendly name has the auto-scaling group name from the API call itself. Similarly, we also have an IAM pass role for this, which is represented by the role ARN in its entirety. So let's take a look at the mapping tool. Here you see the mapping tool in all its glory. It's not pretty, I know. This was really built for function and not form, but I'll take you through it anyway. In the top left, we have an outstanding API method to be mapped. And over here, we have the action that relates to the IAM permission that it needs to be mapped to, as well as the resource types. So for example, start stream encryption requires KMS key and a stream. On the right here, we have all of the properties that are available within the API method request. And this is taken from the JS SDK's API reference. So we have stream name, encryption type, and key ID available as properties in the API request. So we can easily map key ID and stream name to these properties. Once I'm happy with that, I can hit the submit mapping. And this is also hotkey because I was doing a lot of these. If I need to map just an ARN in its entirety, for example, I can hit this little A button. And that means that these variable names will be ignored and we'll just use the full ARN instead. And once I'm happy with this entire flow, I can simply copy the output from here and then paste it into my map.json so I can work on this offline and things like that. So I was really happy with the way that the map.json file turned out, and it was really helpful for me. But I really wanted to represent it in a way that other people can use it. So I made permissions.cloud. Permissions.cloud is an open source website that exposes the IAM dataset information in a clean and easy to read format. It was created in order to provide an alternative, community-driven source of truth for AWS identity. So let's see that now. This is the permissions.cloud website. It can be accessed at permissions.cloud in your address bar. Here we are at the dashboard, and it has some global AWS accounts over time for both API methods and IAM permissions. And we also have a breakdown of permissions by access level. So the amount of list actions and the amount of write actions, for example. You can navigate in the sidebar for specific services, or you can use the search bar at the top to do a search term. And this will produce the IAM permissions, the API methods, or even the managed policies for that search term. So let's take a look at app config. Here we are at the app config permission reference and the IAM actions for that specifically. We have a table that consists of the action name, the description, the APIs that it's used by, and there's often more than one, so this is important. Its access level, as well as the fully expanded version of its ARN, as well as a tag indicating whether it's required or not. If we wanted to look at the API equivalent of that, I can hit this button over here for the specific method, or I can hit one of these to go to the API equivalent for this service. So in the flip side, we have the table of API methods. the method name, the description, the IAM actions that are required, and the ARN template. And this ARN template is constructed with the context of the calling API method in mind. So for example, this application ID here represents the application ID in the API request. And so you can really easily figure out how the request relates to the ARN that's been output. Similarly, we have IAM pass role here, which uses the retrieval role ARN from the request. This little tag here that shows it's overridden, which means this specific permission does not exist in the SAR. This is something that we've overridden and made sure that is in our reference. Moving over to things like managed policies, for example, gives us a full table of all the AWS managed policies that exist in the ecosystem. It shows the name of the policy, the access levels that are applied based on the effective actions within that policy, as well as the current version, creation date, and last updated date. So we can scroll down, for example, and check out a policy. It'll give you the raw policy in all its glory, and it'll show you the effective actions for that policy. So based on the backup asterisk, which is in the policy, it'll show you all the actions that are related to it, including their access level. It'll also point out things like IAM pass role, which is a possible privilege escalation point. And so this is really important for assessing what's in these managed policies and making sure that you're secured in the right way. Every page on permissions.cloud has a download JSON in the upper right, which links back to the iam-dataset. So you can really quickly use this in your own tooling or automation and things like that. I, for example, use this in CloudFormation Guard to make sure that the managed policies that allow in CloudFormation don't have a possible privilege escalation point. So it's really helpful for that sort of automation. And so I was very happy with the way that permissions.cloud turned out as well. But I'm working on something different. And so I wanted to show you briefly what's next for me. This is IAM Fast. IAM Fast is a suite of open source tools which generates IAM policies from application code. So you can see on the right here, we have a block of AWS code, which is straight from the AWS samples website. And it interprets this using a technique called abstract syntax trees, which is kind of how a compiler might look at a piece of code. It takes that piece of application code and generates an IAM policy based on that code, as you can see on the left there. This first iteration is targeting support for JavaScript, Python, Java, and Go. That is not ready yet, still a work in progress. If you're an expert in one of these languages and you want to contribute to the project, please reach out and let me know, because I'm looking for co-contributors to this project. And so thank you for listening to my talk. There's a number of relevant links there, and please fill out the feedback survey. And thank you so much to the 4 CloudSec organizers and the volunteers for putting on a great conference. Thanks very much.
Impressive, Ian. A couple questions. First of all, what is maintenance like for these things, map.json, permissions.cloud? Do you foresee sort of an ongoing maintenance tail as AWS evolves?
Yeah, so maintenance is obviously critical for this. If you've seen some of my work before, I maintain things like console recorder for AWS or Forma 2, which has its own regular maintenance constructs. And this is just something I want to add to my sort of list of things to be maintained. It's not too much work after you've done the initial mapping, but the initial mapping took quite a bit of time.
Do you need help?
Absolutely. So everything here is open source, even the mapping tool itself. And so if you want to volunteer to come in and do some mappings or assess some existing mappings and get a bit more confidence, then yeah, feel free to reach out.
Another question, so like what feedback have you gotten from AWS on this work in terms of, whether they intend to use it to update the SAR or use it to provide internal context? Like, have you heard anything from inside the mothership?
Yeah, absolutely. So I had a slightly more detailed, slightly less fluff, I guess you could call it, version of this slide pack, which I presented to members of the core IAM team back in March. And they've started to act on some of these requests, but I still think there's some issues with the way that the process is as it is. Although some of the things I've mentioned today have been actioned, there have been more things that have come out since that representation to the IAM team. So there's definitely core issue there that I think needs fixing.
Makes sense. And then one more, are there any permissions that are not referenceable by any public APIs? So, I remember sort of historically there were things in billing and support that there was no API, but there was still IAM permissions for things that could only be done through the console or other systems. Does that still exist? How would you find those?
Yeah, absolutely. So in all the references, we have a bunch of services that have IAM actions that don't have any relevant API methods. And so you'll just see a blank for the use by there. This shows account, for example, which I just happen to know off the top of my head, doesn't have any API references, but there's a few in there. And you can scroll through and have a look at what those are.
Cool. Any other questions from the room? All right, well, thank you very much.